Okay, so the last thing I just want to talk about is instantiating instances of a class with, there's two kind of tricks, or not tricks, but just different ways that we can do this, right? So first, let's just look at what we know so far. So I have a class, I copied it. I didn't think you wanted to watch me write this whole thing out, but let's go over it real quick. So this is a class for that holds addresses, right? So it has an init function, just like any other class we've made. It always takes in self as its first argument. And then we're getting a first name, a last name, a street 1, a street 2, a city, a state, a country, and a postal code, right? So that is however many variables. Okay. Quite a few, right? So if I want to, and then I have one other function which just prints the address in a formatted way using this formatted string. That's it. It just prints it out to the screen. So that's it. That's my whole class. So if I want to make a new instance of this class, I'm going to do address. We're going to have to make up some of these values. So what do I need? First name, last name. What's next? Street 1. Street 2. I'm just going to put NA. Street, city, Chicago. Oh my God, is anybody bored yet? Illinois. Country. Say America. Oh my God, see? And if you type really slow, this is annoying. Okay, cool. Looks good. And now I'm going to do a dot print address well. Print it out. Looks good. Okay, so this works, right? But let me finish my sentence and then I want to answer both of your questions. This works, but it is very tedious to type all of these in, right? And so if I want to create another one and another one and another one, the other thing that sucks about this is, what if I accidentally put my address 1 here, right? Or my address 2 here, or I put my name here, then it says I live at Josh, Illinois, 606, right? So the order is super important. And for a function that takes in 1 or 2 or even 3 arguments, that's not a big deal. But once we're talking about, like, sometimes, I mean, this is an address. Some of these classes might need dozens of pieces of information, right? And so making sure I get the order right and typing all that stuff in or inserting all that stuff, it can be really tedious. So there's got to be a better way, and there is, and I'll get to it after I answer Bobby's question and then just question. You're actually good? Okay, what was your question?
So on your print screenshot position of that, I noticed that it actually printed the way that you want it.
Mm-hmm.
And so why didn't you put like new line or something like crazy?
That's just a syntax thing. When I do an F string and I put these 3 quotes, it will maintain anything that I do within those 3 quotes.
So if you just sort of put 1 quote, it would have done that.
No. It's just a 3 quotes thing, and then it will keep track of anything I do in that string. Yeah. Yeah, pretty cool. Okay, cool. So what we want to do is we need a way to really prevent us getting the order wrong here, and then also we want to be able to make these objects much quicker. So what we're pushing toward, and this won't click 100% until probably the end of the week, but I want to introduce it now, is what would really be better is if I had a dictionary with all this information, and I could just throw that dictionary in here, and it would automatically make the objects for me. So let's do that. I'm going to copy this dictionary so you don't have to watch me make the dictionary. And just delete this. So now I have a dictionary with all this information in it, right? And what I want to be able to do is say A equals address. Whoops. And I just want to be able to do address info, right? Like that. So if I do that now, it's going to explode and say there are 7 arguments missing because it takes in 8 arguments and I only gave it 1. And also it was a dictionary, so it didn't know what the hell to do with it, right? It probably set first name to an entire dictionary, right? So there are two different ways we can do this. The easiest way is to use something called a spread operator. Does anybody know what this is?
Yeah, it doesn't, it says that it doesn't know how many arguments it needs.
So go for it.
The spread operator spreads something out into something. So it takes in I'm pretty sure it takes an array. It takes in something.
It can do. I think you can do it with an array or a dictionary. We're doing it with a dictionary here.
So it takes this and then it spreads this information out into this whatever you're spreading it into.
So let's run this and run a dot, and then I'll go over why it works. Actually, first let's hope it works. Yeah, cool. So what did I do with these two asterisks here? I basically told Python, hey, there's a dictionary here, and what I want you to do is I want you to unpack it by key value pair, right? I want you to take first name out, and I want you to basically take first name equals Jeremy out and just pass it to the function, right? And then take last name equals Florence out and pass it to the function. And what's going to happen is the function, the order isn't going to matter here. If I move this all the way down and we run this again, I'm still going to get this. Because what's happening is it's getting passed in as key value pairs. So this is actually looking like last name equals comma, and you get the picture, right? First name equals Jeremy.
And the spread operator in Python is two asterisks.
The two asterisks, right? So what's happening is when I'm making the new address instance, because I'm passing in name keyword, so they're called quargs. You'll see this a lot, quargs. Keyword arguments. So I'm not just passing in values, I'm also telling it, hey, like, I know that you take in something called last name, and I want you to set that parameter to Flores or whatever, right? Does that make sense? I know you take in something called first name right here, and I want you to set it to Jeremy. And by doing it this way, the advantage is one, I only have to pass the one argument. Let's get out of here. Get me back. There we go. And two, my order doesn't matter. As long as my dictionary has all those values in it, it'll unpack them for me in a way that the init function can process. Does that make sense?
Can you go to that example again, please?
Yeah. So
Address info, and then you say you just pass in the key that you wanted, and then you put the value.
yep. So all these key names match the parameter names here. So when I do this this double asterisk, it's saying take this dictionary and unpack each key key value. Thank you. Key value pair with these names. Like call it last name, have it equal this. Call it street name, have it equal this. And it will match because the street name exists here, street 2 exists here, right?
And you go back down.
Yeah.
You done something where you just put in the last name for your first name.
Oh, when I was doing it like this?
Yeah. So
I was just doing that to illustrate what was happening
okay.
under the hood.
If you have an argument that's not, like say you have 8 arguments or 9 arguments in there, what will it do with that last argument? Will it throw an error? Or?
Let's find out. I have a new argument called new with the value new. It will say unexpected argument new. Yeah, because it's going to go through and
Yeah, I get that.
Yes, right.
Good to know what happened, but could you use the combination where, say, for instance, you take away last name florist from your dictionary, or sorry, whatever the first one that you parameter in the subject. Yeah, the first name, yeah. So if you got rid of first name, you pass that, yeah, there.
I know what you mean.
Space.
Oh, you mean just the name?
Yeah, just the first name, just the, yeah.
I don't know. I think it'll work. Yeah, it'll still work.
Now, if you rearrange those, then you should put your error, because two words should always be there.
Because it's order dependent, right? But with the dictionary, if I do it all in the dictionary, the order won't matter. The order won't matter. So those are the two advantages of that, right? Yeah, it's like, because it like spreads. It's hard to like. It basically takes everything in the dictionary and like spreads them all out to their own individual things. Yeah.
You're divided into the second one.
When I had it here.
Yeah.
Because so remember before when we were creating address, it was everything was order dependent, right? So it's going to spread all of these out, and it's going to fill, because it's only doing it by name, right? It's going to do like last name, this. I didn't remove first name. It's going to do all of these, and then because this comes first, it's not going to know what to, basically it's not going to know what to set Josh to, right? Is Josh first name? Oh, but it's actually the second thing. So is it last name, right? Because I'm passing this in first and this in second. So the order is going to be, if I want to do any of these things in order, I'm going to have to do them first and then do this spread last.
So once it takes in Josh, then it's not going to look for a first name.
Right.
So that's
It'll just set it. Right.
But didn't it still print out with your first name not being Josh?
Actually, I don't know. Maybe you're right. Let's see. If I put the first name here. Actually, Holly, to your question, now that I'm thinking about it, I don't know.
I thought it did.
No, it's going to get confused because it's gonna see a first name here, and it's going to get a first name here, and it's just going to throw this error. So if I get rid of Jeremy here and do it, yeah. So anyway, so we kind of went on a little bit of a tangent, which is fine. With this experimenting, this is really good, like important stuff to do, but I would encourage you to do a lot of this on your own, right? Just like mess with tweaking how these things work. The big takeaway here is I can use a dictionary to create these objects, right? And that's going to come into play and make our lives a lot easier going forward. Cool. Great. There's actually another way that this gets done, but it's not. I'll just show you real quick, which is this is actually more of like a Ruby-ish way of doing it. So instead of taking in all of those key value arguments, what I'm saying here is like, I'm just going to get an array, a dictionary, and then I pull each thing out of the dictionary one at a time, right? So I don't have like a bunch of arguments. I just say, I expect a dictionary always. It will always give me a dictionary, and then down here I can just pass it. And I'm just pulling those out like I would pull anything out of the dictionary. Does that make sense? This isn't used as much, but it's just another way to do it. Yeah.
You do it that way, you pass the dictionary with stuff that doesn't.
Then you won't get an error.
You won't get an error.
Yeah. Yeah. So like if I add like new, so it really just depends on what you want, right? And I run this, it should still work fine, right? Because it's pulling everything individually out of here, and it's not going to give me the error at the init, because the init just says, I get one thing, you gave me one thing, cool, I don't care anymore. Like, that's fine, right? So this won't throw an error, and it just depends on what you want. If you want an error, do it the other way. You probably do want an error, but if you don't, you can get away with doing it this way. Cool. Everything I just went over is in today's lesson. Like, so if you want to scroll through and see the stuff I did, it's there. But that's it for this. Any other questions? Okay. So the last thing I want to do is I just want to start your first challenge today with you guys and talk a little bit about what's going to be changing as we go forward. So we're done with algorithms, so some of you can rejoice and some of you can be upset. And now we're going to focus the rest of the week on object-oriented programming. Your first two, or your challenges for today are called apple trees and ice cream and freezers. Apple trees walks you through it a little bit. Ice cream and freezers is much more open-ended, so you're going to have to be making some decisions on your own about how to design and solve that problem. But let's take a quick look at apple trees. I'm going to clone it down and get started with it just to show you a little bit about. So I'm going to forget it. I'm going to clone it from here because I can. Okay. So we have a few more files for apple trees than maybe we're used to at this point. And you're going to be writing a program, and you're going to have files talking to each other, right? So you're going to have to start importing things. Do we know how to import from one file to another? So some of this is set up for you and some of it isn't, right? So you're gonna have to read your errors and let the errors kind of guide you for what you're doing. But let's take a look at what you are actually accomplishing. So you are blah, blah, blah. Okay, we're gonna create a program to model an apple tree growing over the years, right? So you're going to have a spec file here, and you're also going to have a couple of releases that are going to tell you kind of like what you need to implement and how you need to implement it. But let me show you the file structure that we have so far. So spec files are what? Tests, right? And these are unit tests. These are already written for you. All you need to do is make them pass, right? So how do I run my test files if I want to run my Apple spec? Yep. Apple, just the file basically, right? Spec. I forgot. Just the file. So I have in my Apple spec file, I have one test that is not passing right now. So I'm going to have to look at this test and write some code to make it pass. So where do I write that code? My Apple spec file corresponds with my Apple file, right? My Apple is, so I have two classes going on here. I have an Apple class that just handles each individual apple. Then I have an apple tree class, right? So this is going to be new, where our apple tree class is going to have many apples associated with it. So you are going to, at some point, instantiate apples inside of the apple tree class. So you're going to have to think about and work out how that's going to work, right? And then you're going to go down and implement these functions that are set out, or methods that are set out here, right? So I can run my apple tree spec, and I can see all of the tests that I need to get to pass here. And then the last file that's probably new to us is apple tree runner, a runner file. And for our purposes here, all you need to know is like, this is where we're just running all the code that we don't really have a place for, right? So this is the file that you will ultimately run, and it will, you can read through and see what it's doing. It's importing apple tree, then it's creating a new apple tree, then it's creating a loop where, let's see, it's aging the tree. So you're gonna write a method that makes your tree grow older. It's gonna print what the age of the tree is and how high the tree is. Then it's gonna do another loop that is going to, let's see, apple basket. It's gonna pick apples from your tree. And you're gonna have to write some code to figure, once you get all those apples from your tree, you're gonna have to calculate the average diameter of all of them. And it's gonna print some more information and then ultimately end once your tree dies. So what's up? It's so sad, right? Yeah. So I don't want to go over every line of code because I feel a little overwhelmed. Good. Like that's the point of today, is to start diving into a lot more stuff. But I want to give you at least a quick breakdown of what these things are. So you have test files, you have each class is in its own file, and then you have this kind of catch-all runner file that is going to kind of implement all of the classes that you write. Are there questions about this before we go through? Okay, cool. We won't, since you did group project all weekend, today and only today will be pairing optional. So you do not have to pair today. I encourage you to pair, especially if it's a brand new thing, but it will be pairing optional. So start with apple trees, and then you can jump into ice cream and trees. Cool? Cool. That's all I have for today.